Actually, we had that last April in 143. 143 was at some point we presented the stacks and the queues, and we had an homework, a lab about stack and queues. If you remember well, we used stacks to do balance checking of sentence. That was the exercise. And so you know already what is a stack, you know already what is a queue, and you know already how to implement those data types. So let me go through the slides, but I will go like quickly because it's easy for you to understand, and then I will comment the lab number 3, the new lab, which is related to the stacks. Okay. So this is like a review, because we like I said, we already talked about that in 143, and it's the same story. So we studied data structures, right? A data structure may be a very complex system. It may be very easy, like an array, it's a data structure, or it may be very complex by offering like complex operation. Let me change. Okay, better. So we have many examples of data structure like lists and stack. And a data structure is actually a piece of code to hold values with some operation, like insert, delete for list, or push and pop for stacks. When we do programming and when we get interested in algorithm, we have to make trade-offs, because we have to combine many different criteria together. For example, we have to think in terms of time versus space. Means if we want to have a very efficient data structure, very efficient operation, maybe we have to use more space. We can, for example, advantage some operation. So we want to have, for example, some operation very efficient, even if some other will be less efficient depending on how we choose the implementation. And then we have trade-offs about generality, simplicity, performance. Okay, so it's not easy usually to design a good data structure, except for the simple one, especially like a stack, which is easy. You will see in the lab that it's not that easy when you introduce like new special functions, for example. So we ask questions like, can I implement that operation? Can I reuse my data structure? And what are the assumptions I have to make? So all those questions are a lot of questions, and depending on the data structure, it's difficult to answer. I just remind you the terminology we already defined in 143. So what is an abstract data type? The abstract data type is the abstract view of a data structure. That view does not depend on a specific programming language. It does not depend on a specific implementation. It gives only the abstract functions you can use on the data type. And so this is what happens when we say a stack is a data structure where we can store values, and we have functions like push, pop, top, or isEmpty, for example. So we describe in a formal way what are the operations we can do on the stack. Okay, we don't give any information about how the stack is implemented, for example, in C++. what we call an algorithm, and this is what we study in that course. Actually, that course is focusing on the algorithm. An algorithm is actually a process which is a formal process described in a very accurate way, and that process is able to solve problems. That process is expressed in a formal way, so it does not depend on a specific programming language. After you understand how some algorithm should work to solve some problem, you can actually implement the algorithm in different programming language, like Java, C++, C, or whatever language. A data structure is it's different than an algorithm. A data structure is a way to organize some data, and it comes with a family of algorithms to actually use the data structure. So the data structure is like a specific way to organize and to store the data. So like a stack, for example, a stack is storing value, but in a specific way, because we have a small specific set of operation to handle the stack. We cannot do like random things with a stack. We have only a few operations to use. Finally, we talk about implementation of a data structure, which is like a specific way to implement the data structure inside the programming language. And so this implementation, it's another phase, and we could have more than one implementation for one given data structure. That's very easy to understand, and you already experienced that in 143, especially with stacks, because with the stack, we have the array implementation and we have the linked list implementation. There are two different implementations of the same abstract data type. So when we study algorithms and when we do data structure and algorithm and we do software development, we have to implement data structures and algorithm, and we have to make choices and to decide how we do implement. And there is always many different ways to do it, and you will choose the best way depending on the context, of course. Let's move. So for the stack at ADT, you know already that ADT, there are mostly three operations. Is empty to check if the stack is empty, push to add an item, and pop to delete and get an item out of the stack. We can add more operation like top, which is called peek sometime. Top is returning the next value to be popped, but it's not popping the value, just returning the value, but the value remains in the stack. And as you know, we can implement a stack using a linked list or an array, okay? Even different. There is one implementation of the stack in the STL library, which is already done for us by C++. We can use directly. So you know everything about a stack, and you see here a list of possible operations. Create, destroy, for example, push, pop, top is empty, okay? Again, if you need to review that, you can go back to the homework number 2 of CSC 143, not last year, but last April. A stack is very useful because it's very basic and it's used everywhere in the computer. So we have a stack absolutely everywhere in the computer. For example, the computer will use a stack to evaluate function calls. When a function is calling another function, which is calling another function, well, actually the computer will use a stack just to push all the context and the local variable, and then will pop the context when you end the function. We can use a stack to evaluate expressions. This is what you experienced in the project last April, sorry, in 143. Again, we had you had a project which was a mass calculator, and you had to use stacks to handle arithmetic expression. Okay, so what we do when we describe the ADT is we talk about the stack in high-level terms. We say use a stack and push numbers, pop the stack, and blah blah blah. We don't say things like create an array, keep the indexes, and blah blah blah. We don't talk about the implementation. We only say something top-level operation. Another data structure you know already, it's a queue. The queue is another one which is a little bit similar to the stack, is like an easy one. On the same idea, the same way we can describe abstractly what a queue is. We have some operation which create, destroy, enqueue, dequeue is empty. And you know that the two data structures, stack and queues, differ because one is a LIFO because it's a last in, first out, although the queue is a FIFO, first in, first out. So they are different and they have to be used in different contexts. And so those data structures are very basic and they are very fundamental and they are very, very useful because we absolutely use them all the time. And you will see some application in the lab. So for the queue, for the stack, it's easy and you can just get back to 143, but it's very easy to show. No comment needed. For the queue, you know that we have different implementation. For example, you see here the array-based implementation of the queue, and you know that it's a circular array. So we have 2 pointers, 2 indexes, and we can move the pointers from left to right. And when we reach the end of the array, we just like go back. We have also the linked list data implementation, which is very easy. We need to have 2 pointers on linked list. One pointer is on the front of the list, the other pointer is on the last item of the list, and then we can just like enqueue and dequeue. Remember that we enqueue on the back and we dequeue from the front. That's the trick. And so all the operation they get the complexity of 1. So the complexity here is the key point of that course. In 373, we study the data structure and the algorithm, and we care about the complexity. This is why we're trying to design smart data structure and smart algorithm. And this needs to be studied because it's not like trivial. It's not easy just to find data structure. Okay, here we have a comparison between the 2 implementation. This kind of work can be done sometimes when you have 2 different kind of implementation possible. But most of the time we don't need to do it because we choose one obvious implementation which will work for most of the time. But if we have more than one, we can compare them and we can have the pros and cons for both and decide which one is the most suitable to solve our problem or situation. Okay, so this is the only small batch of slides I want to show you because you know already about stacks and you don't need more. You can go back to the textbook. You can go back to 143 if you want to have more, and you can even copy and paste your old code you did in 143 for the next lab. Now, what I want to do now, I want to comment the lab number 3. So let me go to the, let me show you my Firefox window. Okay, so now you see my Firefox. So now in the lab in the labs page, you have the solution of the lab number 2 I just commented before, and you have the subject for lab number 3. Let me comment on this lab.